Okay. Gotta move this just right. I got an email from Leland Hoppe. Apparently I positioned my
You do
camera.
like some of them you do.
You can't see. I know. So I'm trying. He emailed me and said, "Oh, I love the angle. You did a great job." So I'm trying to find out. So this is for you, Leland, if you're paying attention. So anyhow, okay. Well, what the problem is this: is that I have the video right here that I can see, but I also have to look at the assignment itself. So I pop up the assignment. I can't really see the video. So I don't know if I'm even in view or not. So anyhow, section 4.8. We're going to be graphing polynomial functions. Okay. So and we just want rough graphs. Okay. So the very first question, okay, so this is question number 3. I just want rough graphs here. We want to graph, and you're not going to actually have to graph these. It's going to be, here's your equation. You're going to click on which graph is it, okay? And they give us x minus 1, x minus 2, x plus 2. X minus 1, x, what did I just say? Minus 2 and plus 2. And this is really nice because it's in factored form for you. So this one's going to be really, really simple to get a general idea of what this thing looks like, okay? So just by looking, now first off, you should be able to tell, and if you can't, it's not the end of the world, but if you can't answer it, listen carefully because it's a very simple explanation. What degree is this polynomial? I mean, third, why? 3 what? 3 what? 3 x's. There's 3 x's. Bang, bang, bang. 3 x's. Third degree, okay? Now, what you need to know is, remember, if it's an even degree, it looks sort of like a parabola either opening up or opening down, okay? If it's an odd degree, it's either, I call it S or Z shape, like this, or like that. It looks sort of like this or this. I mean, that's stuff you've got to have memorized. You've got to have that memorized for the test, okay? So it's third degree, so it's going to look sort of like one of these, okay? The zeros, you should be able to answer that. You should already have the answers to the zeros. It would be 1 and 2 and negative 2, okay? And that's because if I plug in either 1 or 2 or negative 2, the whole thing goes to 0. So when we graph this thing, we go at 1, we put a dot. At 2, we put a dot. And at negative 2, we put a dot. They are the x-intercepts, okay? They are not the y-intercepts, okay? They're not the y-intercepts. So it's going to hit all 3 of those points, okay? Now, is it going to look sort of like the first graph or the second graph? Well, there's no negative here. If there's a negative out front, it's going to slope down. Well, there's no negative here, so it's going to go up. So if something goes up, we forget about math, if something goes up, it has to start where? Down. It has to start down, okay? So it's going to start down here. Now, this is the part, I'll be honest, I don't remember if I told you this or not, okay? What happens, I know we've talked about this before. What happens at negative 2? Does it go across or does it bounce off? I heard both. I heard it says it bounces and I heard it crosses. It goes back down. Remember? It goes through. Why? It's raised to what kind of a power? An odd power. Specifically what? Well, okay, the whole thing's 3, but these are raised to what power? You don't see it, but they're there. They're what? 1. Okay? If it's raised to an even power, it bounces, okay? These are all raised to the first, to the first, to the first, okay? So it's still third degree, but it doesn't bounce at any of them, okay? So it crosses over. And it has to swing back down, and it goes up some, okay? I don't really care how far it goes up, but it's got to swing back down and hit this. It's got to hit 1. And what happens at 1? It doesn't bounce, it goes through. And it goes down some, okay? But it's got to swing back up and hit 2. And there it crosses over also. It doesn't bounce anywhere, okay? If this right here was squared, it would have bounced at 2. At 2, it would have bounced back down. And not only that, what degree would this be? Would it still be third degree? This is a little bit tricky. How many x's are there? Looks like there's 3 of them. It's actually 4 of them. Where's the 4th one hiding?
0.
Well, x minus 2 squared. So that means x minus 2 and x minus 2 again. There's 2 x minus 2's there. So that'd be 4th degree. It'd be a parabola. Okay? So that's it. Okay? You click on the one that, and there's only one of them that, I'll make sure here. The only one that goes through that. Yeah, that one's, yeah, that's the only one that fits. Okay? So, let's look at number 5. Okay? Now, on your test, it's not going to be click on the right answer. It's going to say, give me a rough graph, and you're going to do something like that. Just a real quick rough graph. Okay? How about x plus 1, x minus 1? Y equals x plus 1, x minus 1, and what? Totally off topic here, but I'm just curious. Wrestlers. When's your first meet? Is it this week?
Friday.
Friday?
We have one Friday.
Is there a lot of guys that have to cut a lot of weight?
Me.
You? That sucked yesterday. You probably didn't eat hardly anything for Super Bowl, did you? That hurts. You know? So, oh man, that sucks. So, I had enough for both of us, so okay. All right, so this one right here, it's third degree. Okay, it's going to be third degree, and it's still opening up. There is no negative, so it's going to look very similar to this. But my zeros are going to be -1, +1, and -2. Okay, and again, I've said this several times. You know, I just want to make sure. Don't be saying, well, I got that because you take the opposite. You're not wrong, but I think a better way of saying it is, it's not that these are the opposites. What turns this into 0? What do you add 1 to make 0? -1. What do you take away from 1 to make 0? +1. Okay? All right, so let's plot these. So we have -1, +1, and -2. Okay? And again, it's going to look very similar to this, just different zeros. It's going to go up, so it has to start down, and it doesn't bounce anywhere because they're all to the first power, which is odd. So it goes up some, goes back down there, goes down some, goes back up. Very quick, ugly, rough graph. Okay, number 7. Am I still in the view of this thing? No, I'm not. I got to turn it. Sorry, Leland. Okay, number 7. Okay, let's get into a little more interesting ones. The first two look almost the same. So number 7, we have x minus 2 squared. X minus 2 squared. And then what? X plus 1. So again, we already kind of talked about this, okay? How many x's do you see there?
3.
You see 3? You actually see 3 of them?
We see
You see 2, but it's actually third degree because the one that's hiding is, when it says x minus 2 squared, that's x minus 2 times x minus 2 times x plus 1. There's 2 of them here, so it's really third degree. Still third degree, so it's still going to look sort of like these. It's still going up. It's not negative. It's still going up. Okay, my zeros are 2 and -1. How is this one going to be a little bit different, though?
There's 2, so...
So what? It's raised to the power of 2.
So it's going to bounce.
It's going to bounce at 2.
Even.
It's going to bounce because it's an even. Now, be careful. Is it bouncing because this 2 that I just wrote right here is even?
No.
No, it's because this exponent is even, okay? So it's going to bounce. I'm going to write the word bounce here. The graph's going to bounce at 2. It's going to bounce off the x-axis, okay? Remember, that's like when I was talking about when I opened up the door and I said I could get to the door and I could go through into the hallway or I could bounce off and go right back into the classroom. So let's plot these. So we have 2 and -1. It's still third degree, okay? It's still going to look sort of like one of these S-shaped curves or Z-shaped curves, okay? So, and it's still positive, so it's still going up, so it's going to, if it goes up, it starts down. What happens at -1? It doesn't bounce, it goes through, goes up some, goes back down and hits 2, but it bounces at 2. It goes like that. So it's third degree, but how many places does it touch the x-axis?
2.
Only twice, because it bounces at one of the spots, okay? All right. Next one. So I was talking about, if you're sitting there going, man, this isn't that bad, then you're sitting really good because most of this assignment, there's a few, there's one other thing we have to talk, we probably aren't going to talk about today, but there's one thing that kind of gives students some difficulty later on in this assignment. Number 9, so we have x plus 1 squared, x plus 1 squared, and then what? X minus 1, x minus 3. I'm going to shut my mouth here for about a minute, and I want you guys to go ahead and do this. Okay, don't wait for me, okay? I'm going to give you the answer in a few minutes, but try it on your own. If you can do this entirely on your own and get it right, you're sitting really, really good. While you're working, though, I'm just curious, is this going to kind of look very similar, like an S-shaped curve again? Is this, what degree is this thing?
4.
Fourth degree. So is it going to kind of look like this S-shaped curve?
No.
It's going to look like a parabola. Kind of like a parabola, okay? Okay, the zeros were -1, +1, and +3. It bounced at -1, so it's raised, again, because it's raised to a power,
Even.
it's raised to an even power. It has to be raised to an even power, okay? Okay, so it's gonna bounce at -1. It's sort of a parabola. It's sort of a parabola opening up because it's not negative, okay? Since it's opening up, it goes like this. It bounced at -1, went up some, okay? Went back down and hits +1 and didn't bounce there, so it went through and went down some. I mean, is this supposed to be higher or is this supposed to be lower? I mean, should this be higher up or lower down? I don't care. I really don't care. Okay? It goes up some, it goes down some. And I mean, somebody else does this. Somebody else does this dotted one. Who's right?
Both.
You both are. That's good. I don't. You're both fine. Okay. Number 11. Okay.
How many questions are in this section?
How many are in the section? What section? Let's see. Second hour. There are. Where are they at? Oh, I was going to say 12. That was the last section. 22.
Oh,
So not a ton. Whoops, I'm in the wrong assignment there. Okay, let's look at number 11. Problem number 11. Okay, so we have 1/5. Is that what it says? 1/3. 1/3 x minus 5. X minus 5, then what? X plus 2, x minus 3. X plus 2, and x minus 3. Okay, so we've got a number out front this time, okay? It's gonna shrink it vertically because it's less than 1, and it's still positive, so, I mean, it's not that much different. So our zeros are 5, -2, and +3. It's not gonna bounce anywhere, okay? They're all raised to the first power. It's 3rd degree, and it's opening up, or going up, not opening up. So we have 1, 2, 3, 4, 5. -2, so at -2, +3, and +5. Okay, so it's going to go up and it doesn't bounce, it goes down. Just want to make sure, is there any of them that's the only one that goes 5, let's see, 5 to 5, 5, and yeah, okay. All right. Now, again, I just want to point out here, you guys said, I think I heard IOB say that I was supposed to shrink this thing. You go, oh, crud, I didn't shrink it. So I'll go like this, and then I shrunk it, okay? Who's right? They both are. I want rough graphs, okay? So I wouldn't worry about that 1/5, other than that 1/3, not 1/5. I don't know why I keep saying 1/5. Okay, number 13. Not number 13, I'm sorry. Next problem is number 15. Okay, they give us, I tell you what, it's one of those where they made a mistake, and you need to find the mistake, you need to fix the mistake, okay? All you gotta do is click, I mean, it's the same thing, okay? So here's what we're gonna do. We're just gonna do it, okay? And then you can find out what the mistake was. Okay, so the one that they did incorrectly was this, y equals x plus 2, x minus 1 squared.
so you should have it sorted down.
Yeah, because what it does, it says, where's the mistake? They did it incorrectly, and they said, what's a mistake? And then they pick the right one. So you're going to have to do it anyhow. So, all right, so I'm going to shut my mouth here and I'll have you guys start. While you're doing it, I'm going to put down the wrong answer. Okay, so go ahead and do it the right way. I'll put down the wrong answer, see if you guys can figure out what they did wrong. 1, 2, 2, -1. Anybody tell what they did wrong? Yes, ma'am.
You bounced at -1 was supposed to go through and then bounce at +2.
You're not wrong. You're totally right. There's a simpler explanation.
Flipped it.
What do you mean?
It's like it's upside down. Wait.
It's supposed to bounce.
It's supposed to. Yeah.
Tell you what, you're still up, Hope. What's the first thing you did when I said, did you already do the right way? What'd you do first? Found the x-intercepts, okay. And then did you plot them?
I seen that it was,
So what'd they do?
this was squared.
Okay, squared, so then it was bounced, okay. Then did you start graphing them? Okay. So, what are their x-intercepts? No, this is, this is the right way to do it wrong, okay?
This is the right way to do it wrong.
That's right, not the wrong way to do it wrong. So,
Their intercepts are -1.
right, they said the intercepts are 2 and -1. Their x-intercepts are wrong. They got the wrong x-intercepts, okay? So, I mean, if the x-intercepts were wrong, if the x-intercepts were right, did it bounce at the correct spot right here? Yeah, okay. So the that's what you need to click on. The x-intercepts are wrong. And then what they should have done was add -2 and +1. And let's see, this thing went bounced at 1.
No, it went through.
No, bounced at 1, right?
Oh, yeah, bounce.
Yep. All right, should have been that. Okay, they had the wrong x-intercepts. Okay. 17. How many more of these? Let's see. One more. I'm going to do one more with you guys. And then this will be the last one I'm going to do with you guys here. Okay. All right. Okay, find all the real zeros of the function. Okay, in this case, you're not graphing it. They want the real zeros, okay? So we've said this over and over and over. It says f of x. Are you going to write down f of x?
0.
You're going to write 0. 0 equals x3 minus 4x squared. Okay, minus x plus 4. Minus x plus 4. Okay, and I've already said this name once today. I'm going to say it again. Mr. Hoppe emailed me last week, and he said, Kale, how do you know when you're supposed to factor by grouping? If you remember, one of the previous sections, a couple sections back, it was like 4th degree, and I said, here's some answers. Here's some answers. Figure out the rest, okay? Remember that section? You did the synthetic division stuff? And the reason was factoring by grouping didn't work. If you remember, and I only said this one time, okay? When we started doing that section, I said, just watch me try to factor by grouping. Just watch me try, okay? And I said, don't write this down. Don't write it down because I tried to factor by grouping and I couldn't, okay? That's when I had to give you some answers, okay? Leland said, how do you know when you can factor by grouping or not, okay? I'm going to make it easy for you guys, okay? On your test, if I say, here's some answers, okay? What does that tell you?
You're not grouping.
You can't group them. You can't do it, okay? To make it easy on you. So basically, when I first taught you grouping, okay, it was when you had 4 terms, okay? So let's try to say this really carefully, okay? I ain't giving you any answers this time.
Uh-oh.
Why?
Grouping.
Because you can factor by grouping, okay? So to make it really, really simple for Lionel, I said, if I give you answers, you can't group them, okay? If I don't give you answers, you can group them, okay? Now, if I give you something like this, would you do that by grouping on this one?
You can't.
You can't. Forget about math right now, okay? Could I take these 3 ladies and put them in groups, plural, groups? Forget about math and use common sense. Could I take these 3 ladies and put them in groups?
No.
Could I take these 4 students and put them in groups? Yes, you can. Why can't I take 3 people and put them in groups?
Because there's only be one group.
You have a group of 2 and a group of 1? That doesn't make sense. Group means more than 1, okay? You can't do it. You can't group these because there's only 3 of them, okay? So, this one you can factor by grouping. So let's do the first 2 and the last 2, okay? This is good review from earlier in this chapter, okay? It's been a while. I just thought, I forgot this stuff. Okay, that's okay. You're going to need to know it next Tuesday, though, when we have our test, okay? So, and we'll definitely review. We will definitely review for this test. Okay, so what can I factor out of x3 and 4x squared?
X squared.
X squared times x is x3. And what can I take? I take x squared times what's 4x squared? 4. Now be careful on this one. It's been a while since we talked about this. What can I factor out of these 2 things? What can I factor out of negative x and 4? Only one thing. 1, but am I going to factor out a 1? Not 1.
Because
Why negative 1?
Because the 4 is
Well, because, don't look over here though. When do we factor a negative out? When do you just see a negative anywhere? When you see a negative where?
Out front.
Out front. So factor out a -1 times what gives you negative x? Positive x. -1 times what is +4?
4.
Okay.
-4.
-4. Okay. I always pick on her, but oh well, 'cause I know she knows it. Jordan, you like what we got up there?
Yeah,
Why?
because it's the same.
What's the same?
The stuff in the front.
If the stuff in the parentheses wasn't the same, would you be happy where we're at? No. Stuff's gotta be the same, okay? And how many, and again, some of you guys are still struggling with this, okay? Watch carefully, because once you get, it sounds really weird, but I mean, you gotta be able to get this down. And when it says x minus 4, how many x minus 4s?
2.
Not 2, that's not what it says.
4.
X squared of them. There's x squared, just like if I give you this. How many x minus 4s are there? 3. How do you know that?
3 out.
It says so. How many now?
13.
13. How many now?
W.
W. W squared of them, okay? There's x squared of them here. How many of them here?
-1.
-1. So altogether we have x squared minus 1, what? X squared take away 1, x minus 4s. And again, I'm not trying to embarrass anybody here. But if you can't answer this, you got some work to do in the next week. Does this possibly factor further, x squared minus 1? Does it definitely factor further? Definitely. 3 words to be in your head right now. Well, 3 words. Something, something, something. X squared minus 1.
4.
No, 3 words. That's a difference
Of square.
of squares. That's what squared?
X squared.
Don't say squared. What squared?
2.
No, no, no. What is squared? X. What's squared here? 1. So x plus 1, x minus 1, x minus 4. What are the zeros? -1, +1, +4. Okay? All right. There's one more thing we need to talk about, and we'll talk about that tomorrow, okay? So, again, and we're doing this because, like I said, I think that we could probably, we need 2 days of review, okay? And I don't want to give you a test on Monday. We're going to give you a test on Tuesday. So, I mean, if you really, really wanted to, some of you guys could probably hammer out all the way up to question number 18. You can get number 18. Don't move on. Number 8, after number 18, we jump all the way to number 39. We have not even talked about that yet. I would really discourage you from moving on to question number 39, okay? So tomorrow we'll talk about that. Thursday will be a work day, or Thursday will probably still be a work day. Then Friday and Monday we'll review for our test. Okay, the rest of the time's yours, guys.